Let's see. How do I see? There we go. Okay, so we want to make like a voxel game. And I don't know if this is gonna be a game or if I kind of want to just mess around. Because one thing I want to learn how to do is, I mean, there's a lot of things I want to learn how to do. One thing is getting like JavaScript support for my game early on. I kind of want to learn how to do that. So maybe I'll do like, I'll just code a super simple terrain generation thing and then, actually, maybe I don't even do terrain gen. Maybe I just do like, I do like a fixed size world and then you could just like build in it. It's like a sandbox, but then you can like make mini games or something. So let's go ahead and create a new script. We're going to call this chunk. And we're going to do a little bit to this. But right now, we're going to leave it empty. Actually, we're going to get rid of mono behavior. Because we want to create another one called dimension. I don't think Minecraft can copyright this system, like the dimension in the world and stuff. So dimension is going to get, I mean, I guess it could be mono behavior. We'll do public. Do we want public? Yeah, public transform because we want the player. Actually, no. This is going to get, actually, yeah. Or maybe not. I'm not sure. What should dimension do? Dimension's going to be handling any noise if we're doing like noise calculations or anything. Okay. So maybe we don't do a dimension thing because I don't know if I'm gonna do noise, to be honest. I always wanted to make a survival game, but I realize how much goes into a survival game that I kind of just don't want to make one, you know? So maybe instead I make like a instead of the dimension, we'll do world or something. This is basically just going to be what houses terrain generation. Well, not terrain generation, but chunk generation. I could call it chunk generator, but I think it's going to do a little more than that. So yeah, I could just call it world. I'm just trying to think of like the Minecraft JavaScript system. That's like the only time I've ever really made mods for a game. And so it's the only game I know with confidence how things are laid out when it comes to um, functions and the JavaScript engine and all that kind of stuff in the game. And it kind of gives me an insight as to how they built their classes for handling things. Where, like, the dimension, you can get all the entities in that dimension and then stuff like that. But that's because the world will be loading multiple dimensions at a time, which I guess could actually be good. Because then I could like add a block, which will be like the dimension portal. And it'll be like a portal that you can just like travel between the dimensions and you'll kind of act like the dimensions are um So yeah, maybe we do dimensions and then we could have, because like let's say we run a server for this, we could have multiple dimensions running on a single server instead of having to have multiple servers per like, because you can think of it as a lobby. How like regular servers they handle it in lobby systems and you'll like teleport between the servers through the lobby. Shit. I keep responding to people on Discord. I need to stop. Okay. So we got world, and then let's go ahead and bring back dimension. We'll just, or we could do lobbies. Lobby. I guess it's not really a lobby though, huh? Yeah, we could call it dimension. Also, I don't know what this is. Unity 6 has so many little errors like that, and I just don't know what they're for. I kind of ignore them because I can just clear it. And it doesn't affect the actual build. It's like some editor things. Okay, so this is going to have a private list. This is going to be system generics of chunks. We're going to call this chunks equals new list of chunks. And then in probably in chunk, or probably in this, we'll get a private world. Actually use lowercase. There's no reason to use uppercase. This, I guess, can be a mono behavior. Unless I want to instantiate this as a reference object, or not a reference, a I guess we could do private void load chunks. And this is either going to take a list of chunks called chunks equals null. If chunks equals null, then we will do, else we'll do chunks is equal to chunks. if chunks is null, that means that we need to load brand new chunks. So what we'll do is just generate a single chunk at 0, 0. Generate chunk new vector3 int 0, 0, 0. Private void generate chunk. Pause. We'll actually call this chunk chord. And then we'll do chunk is equal to new chunk. Pass in world. I don't think the chunk needs world though. I think it just needs the dimension. So this and chunk chord. And then we'll do chunks.add. Then over here, we're going to need a private vector3 int. I'll actually make this public because it needs to be public. Public chunk, actually vector3 int chord. This will be get private set public dimension. No, this one's going to be private because we don't need to save this. Dimension get private set. Well, actually, no, that'll just be as simple as that. And we'll do a public chunk. And then dimension, and vector3 int for the chord. And then we'll do private game object, chunk object. This dot chunk object is equal to a new game object. We'll name it chunk plus chord dot. Actually, I'll just do chord. Actually, don't need to do that. Then we need a private mesh renderer, private mesh filter, and then mesh filter is equal to chunk object dot add component. Mesh renderer is equal to that. And then dimension should have its block list. And I wonder if maybe I don't do I'm trying to think, should I do it as actual blocks like with textures and stuff, or do I want to do each pixel of the block like in Minecraft how there's 16 pixels per block? Do I want to make it so instead of 16 pixels it's like each pixel is its own block, and then each block technically would just be a color, it's not a texture? because then I could do mesh renderer dot material is equal to new material. And then I wonder, can I just pass a shader in here? Yep. Shader dot shader dot get shoot. I guess dimension will just have the material. Public material. Dimension material. Get private set. Actually, no, we can't do that. It's got to be like that. Is equal to dimension dot dimension material. Actually, we could call this block. And then what we want to do is we're going to do chunk object dot position transform dot position is equal to chord times 16. I think that's right. Yeah, it's 100% right. And actually, we'll do this before we add the mesh stuff. Okay. Then this is also going to need a public. We could probably do byte array. This is going to be 3D voxel map. So that'll allow us to assign the voxel map. So now I think we could just test it. Start. Load chunks with nothing. Then we'll do this. Dimension. Reset that. Add that. Make a new folder, call this materials. Then we'll just have a plain material. Blocks. So we got chunk 0, 0. Perfect. Now we just need to create a mesh for this. So we could do that by, first we need populate voxel map. We'll actually put this down here. And then we're going to put this here. Then we'll do private void populate voxel map. And then voxel map is equal to a new byte array 16 by 16 by 16. And for x is equal to that. And then voxel map of x, y, z is equal to probably just 1, I guess. And then populate mesh data. This is going to do about the same thing here. Except for it's going to get the voxel. So I'll have a private byte get voxel. This is a byte with a question mark. And then a vector3 int local voxel pause. We'll just do voxel pause because we think it's going to be local, but it might not be. Get voxel. Actually, this is going to return. Wait, can I return -1? Is that like a possibility? No. But I can return 0. So 0 will be like air or nothing. So what I'll do is private byte get voxel vector3 int global voxel pause. And then this is going to be if global voxel pause. Well, actually, we want to get a. How do I want to do this? You know, it'd be a lot easier if it was a procedural terrain generation, because later down the line it would be harder, but right now it'd be easier, because when I get the voxel, if the chunk doesn't exist, then I can just use the chunk generation script. But because we're not doing infinite terrain generation, we're not going to have a generate class. So instead, we're going to do if global voxel pause. Shoot, no. Again, I need to get the chunk chord. So we'll do vector3 int chord is equal to global voxel pause divided by 16. Can I do that? I don't know what that does though. Does it round down or just round? Because I need it to seal. New vector3 int. Or actually I could do vector3 int dot seal to int divided by 16f. And we'll do vector3. So that'll be our chord. And then if also do a dictionary vector3 int chunk we're going to get rid of that. We're going to do that also means that this can be private. This will be chunk chord and chunk. this is going to take in a dictionary of this. And then this is going to say if chunks dot contains key actually we'll just do chunks dot try get value global voxel pot or chord out chunk return chunk dot voxel map of global voxel pause minus chord times 16. We'll do vector 3 int local voxel pause is equal to that x local voxel pause dot y local voxel pause dot z is equal to, well actually no, we'll just return that, else return 0. If voxelpause.x is less than 0, or voxelpause.y is less than 0, or voxelpause.z is less than 0, or voxelpause.x is greater than 15, or voxelpause.y is greater than 15. The reason this is greater than 15 is because if it is 16, that is greater, and we don't want it to be 16 because the byte array is always going to have the index starting at 0, which means 16 is actually outside of the 16 inside the array. So voxelpause.z is greater than 15. Then we will do then we're going to do well, I guess it depends, because if it's -1, the only thing it's ever going to be is -1 or 1 or 16. So if it's 16, we kind of want to remove that we want to remove 15 from that because we want it to be 1, because then we can add that to the chunk chord in a localized world position. And then that just gives us +1. Oh, wait, no. That's right. Yeah, I just add the 2 then. So vector 3 int global voxel pause is equal to voxel pause plus chord times 16. Then return dimension dot get voxel. This needs to be public. Get voxel global voxel pause. Else return voxel map of voxelpause.x, voxelpause.y, voxelpause.z. Okay, So what this is going to do is it's going to check and see, is the voxel pause inside of this chunk? If not, it's going to go to the dimension and try to get the voxel from the neighboring chunk just to see, like, what is the block there. Else, it's going to return our voxel map as itself, like the voxel that's there. So then what I could do is if voxel map of XYZ does not equal 0, then we'll do add voxel. We'll actually call this build voxel. Build voxel mesh. Private void build voxel mesh. And then this one is going to basically build the mesh for each voxel. And this is where we're going to be using get voxel. So we actually need another script before we move on. And this one's just going to be called voxel data. Actually, I'm going to rename it to voxel mesh data, so it makes a little bit more sense. Because it's not actually just a... Oh, shit. Voxel mesh data. Does that rename it here? It does. Okay. So this one's actually going to be a static class, so we'll get rid of the whole mono behavior. And in case you have never seen Unity or don't know exactly what I'm doing or don't really understand what I'm doing, the reason I learned all this is because of Beegs, B3 or B, yeah, B3AG, Jesus, B3AGZ on YouTube. I watched his Minecraft thing years ago, and I've watched it many times when I was like first learning Unity and trying to understand everything. So I have the information in my mind stored deep in my brain from a while ago when I watched it. So I kind of know the layout of how he did it. And then I also know the layout of how Minecraft does their stuff. Not their actual coding, but like with the scripting API, I know that. So combine the two and I kind of know how to make a game. Or at least I know some aspects. So this is going to be a public static read-only voxel verts. This is actually going to be a vector3 array, which is equal to a new vector3 array with 6 vertices. Actually, this is 8. And it's red because we need to actually add them. So we'll start with 0F, 0F, 0F. Then we'll copy this. Four times, and then we'll do 1 over. So that's basically right here, and then here. Actually, no, we'll switch this around. We're going to do 1. And then we'll do 1. And then we'll do 1, 1. Then we can copy all this and just add 1s here. Okay, so that's our vertices. Then we have our voxel triangles, which is going to be an int array. This is going to be a 2D array. Which is going to have 4 and 6. Or 6 and 4. Reason for this is because we have to build triangles, and actually, yeah, we'll build triangles just to save Unity's performance. And what I mean by that is every mesh is composed of triangles. So each face that we see on a cube, so there's 6 faces, we have to actually build the triangles from the vertices. So let's say, you'll see it a little bit better later on, but the reason why it's not 6, because if you think about this 6 right here, this is basically saying, hey, there's going to be 6 here. So like if I remove these 2, that's 6 total. But then the second part of the array is saying that there's 4 in each one. So like this, and then I'd do like 0, 0, 0, 0. And that'd be the 4 vertices for that triangle. See? And so this is going to be the index of these to build this face. So first we'll do the south face, because that's going to be the one facing the player. And I'm actually going to do probably quads. I'm just going to build it as quads. So we're going to go counterclockwise starting in the bottom, or we're going to go clockwise starting in the bottom left of the face. So in this instance, it's going to be 0. But actually, before we even do that, what I kind of want to do is go over to dimension, and we're going to do on draw gizmos. And then we'll do for each variable vert in voxel mesh data dot voxel verts. We'll do gizmos dot draw sphere with vert with a radius of 0.1. Now, just like that, we should be able to see some spheres. So this is our vertices. And then really quickly, what I could do is also do, I don't actually remember how to do this part, so I'm going to look on ChatGPT. How to draw text with on draw gizmos Unity. Handles.label. Okay. So we'll do handles dot label with vert plus vector3 dot up times 0.15 f. And then we will do that with, or actually we'll just do I dot to string. That also means I need int I is equal to 0 and I++. That might be too low though. Nope, that's good. Okay, so now we could see that. And I'm also going to do vert plus transform dot position. Reason for that is so that I can move this out of the other gizmo, because I don't want to have to disable it. And then I'll just do that. Okay, so here's our vertices, and this is the index of each vertice. So this is going to be really useful for kind of seeing when we're coding. So now we can do our triangles. So we're going to do the south face, which again, I said is the back face. So this is the one facing the camera right now. Because if you think about it, Z is going to be facing out this way. So like forward that way, which means if we're going by positive Z being north, then this will be the north face, these 4. Then the south will be these 4 on the back. Then east on this side, and then west on this side, top, bottom. And so if we're doing south, this is going to be 0, 1, 3, 2. 1, 3, and 2. Then we could flip this around and look at this. Now it's 6, 7, 5, 4. And that's going to be the north face. Then we'll do our east face, west face, top face, bottom face. So now we have to do east, which is going to be this one. So we'll do 2, 3, 7, 6. Then we'll go on this side, and we'll do 4, 5, 1, and 0. And the reason I'm going clockwise like this is a specific order. It doesn't matter where I start with this. Like I could start with 0, 4, 5, 1, but then the UVs are going to be rotated. So the reason why I'm doing it this order is because when I build the triangles and the UVs, I'm going to have to map that with the order that I'm also doing this, because if you think about a UV, it's basically an unwrapped version of this. So when I do the UV, it's going to be like 4, 5, 0. That's going to be the first triangle. And then the next one is going to be 0, 5, 1. And so that also means that this is going to be, you know what? We could probably just switch this out to 6, because this is going to make our lives a little bit easier when it comes to actually setting up the triangles. And what I mean by that is, the reason I was doing 4 is because I was going to think about just doing quads, because with Unity, I could just like build a mesh with quads rather than triangles. And that'd save me from doing all the calculations, but then I'd have to have Unity automatically convert the quads into triangles because it has to render it as triangles. And that's like kind of relying on Unity to do a better job at performance sake than me. And I don't know if it's more performant. I'm not really sure. I don't think the scene's big enough for me to actually notice a difference. But just in case, maybe I'll just do this. So we're actually going to go back and we're going to go 0, 1, 2. And then it's going to go 2, 1, 3. So 0, 1, 2, 2, 1, 3. Then we'll do this side. So 6, 7, 4. 6, 7, 4. And then 4, 7, 5. 4, 7, 5. And then, as a matter of fact, we can actually remove these two. So we're actually bringing this back down to 4. And that's because this is now the order in which it's going to, like, we already know that these are duplicates. So here, I'll do the east face so you actually know what I'm talking about again. So 2, 3, 6, 2, 3, 6. And then 6, 3, 7. So 6, 3, 7. Remove these last two. And now you'll see that it goes 2, 3, 6, 6, 3, 7. Which these 4 right here are basically just duplicates in reverse order. So when I'm doing the code, I don't actually need all 6 in this array. Instead, I could just like do the math and be like, hey, this one's going to be like 0 plus 0. This one's 0 plus 1. This one would be 0 plus 2, 0 plus 3, 0 plus 4, 0 plus 5. But instead, since they're basically the same numbers, and I already know that it's going to be in the correct order, I could just be like 0 plus 0, 0 plus 1, 0 plus 2, 0 plus 1, and 0 plus 3. And also, it's going to be 2 and then 0 plus 2, and then, yeah. So that means I can now get rid of the 6, 3 part of this. And this one's going to be 4, 5, 0. And then 1. Because 4, 5, 0, 0, 5, 1. Then we'll do the top face, and I'm going to do it in this order. So I'm going to look at it from, like, if I was facing north, and then I just, like, looked straight down. That's what this would look like. So this is 1, 5, 3, 7. So 1, 5, 3, 7. Then on the bottom, I'm going to do the same thing. It's going to basically reverse the order. So now it's 4, 0, 6. What is that? 2. 4, 0, 6, 2. 4, 0, 6, and 2. And now this is the UVs. Hold up, let it load. So then we're going to do that, and we're going to do voxel UVs. This is going to be a vector 2. New vector 2. This is also going to be 6. And then 0F, 0F. And now this is where you're going to see what I meant by the order actually matters. Not necessarily for the UVs, if I were to correct it here, or not necessarily for the triangles, if I were to correct it here. But instead of correcting it, now I can just look at it, and I basically, I went in this order. So now I just do the same thing with the UVs. So this is going to be 0, 0. Then the next one in the triangle list is up here. So now we're going to do, if you think about it, that's up 1 on the Y. Then this one's going to be over 1 on the Y. And then I can actually reduce this to 4 again, because we know that there's going to be 2 duplicates. And then 1, 1. And so just like that, that's all we really need to build out a triangle. Or a cube. So, what I want to do is, instead of doing all this, we're actually going to set 0, 0, 0 equal to 1. Oh. X, Y, and Z. And we're going to set these to 0. And then at the very end, we're going to set the 1 over in the corner to 1. So that's basically going to generate 1 cube. And then we'll come down here, and we're going to go for int I is equal to 0. I is less than 6. I plus plus, because that's going to be our 6 sides. And we're going to do for int P is equal to 0. P is also less than 6, because now we're looking at the 6 points in the triangle arrays. And then we could say vertices. We don't have an array for that. Let's go back up to the top. Let's make a new private list of vector 3s. Call this vertices equals new list of vector 3s. Private list of vector 2s. This is going to be UVs. And a private list of ints, which is triangles. Now back at the bottom, let's scale this up. We can now say vertices dot add, and actually before we do that, we also need a private integer for vertex index. This is going to be the index so that we know how much upon the triangles we're actually adding. Because if you think about it, this is not going to be the same every time, because if we're calling 0, that's going to be the first vertice ever added into the vertices array. When in reality, we want this to be added upon the other vertices, basically. So, like, we're going to be building on each mesh. So, let's say there's 36 triangles, 36 of these inside of one cube, one full cube. And then let's say we wanted to draw a second cube. Well, we want to add from the vertex index, because that's going to increment each one. So at the end of this is going to be 36. So it's going to be 36 plus 1, or technically 35, because that's the size of the array, because you start at 0. And so that's going to happen each block. But also, since you're going to have faces that aren't actually rendered, that's why we have a vertex index, and we're not just counting it up by 36 as a static 36 every block. So then down here, we want to do vertex index plus plus. And then we want to do vertices dot add, and this is going to be voxel mesh data dot voxel verts with the index of voxel mesh data dot voxel tries with vertex index. Or actually, no, this is going to be I and P. I and P. And then triangles dot add, and this is going to be vertex index. So basically what we're doing here is we're getting the triangle index, and we're going to keep looping over all of these points through this and adding the vertices that this is assigned to. So it's basically like, you know, like this one's going to add 0 when P and I are both 0, and then the next one's going to be that, and, you know. Actually, what I just remembered is that we're not actually doing it like that. So instead, we have to do boom, boom, boom. So that's 4, 5, 6. So this is vertex index plus 1 plus 2 plus... This is plus 1 plus 2 plus 2 plus 1 plus 3. And then UVs dot add, and then we'll just do voxel mesh data dot voxel UVs of, we'll just do P. That would have to change if we were doing individual stuff and like splitting the, like an atlas texture into individual segments, but for now that'll work, because that'll just take a single texture per mesh, or per material. And then this right here, I think needs to go plus equals 6. Because we're adding 6 triangles to it. Possibly. No. It does need to be plus plus. Because we're only... This is the vertex index, and technically we're only adding 1 vertex. Okay, and then build voxel mesh, and then we'll do private void apply mesh data. We'll actually call this build mesh data. So we have populate mesh data and then build mesh data. So this is going to do mesh. Mesh is equal to new mesh. Mesh dot vertices We'll actually do set vertices, and then that's it. Mesh.set triangles, that's going to be on the 0 subindex. It's basically because we can have multiple sub meshes in a mesh. So it could be like 6 different chunks in a single mesh, but we're not doing that because the reason why our mesh is so small in the first place, like 16 by 16 by 16, is because anything larger is really just like, it's gonna cause a lot of issues when it comes to vertex count per mesh. Because if you think about every single voxel possibly having full encapsulation of like every face is rendered, that already just a full chunk is an absurd amount of vertices. Because remember, it's 36 vertices per mesh or per voxel. So if every single one was to render, that's 36 times how many blocks is that in 16 by 16 by 16? It is 4,096. So times that by 36, that's 147,000 vertices that you'd have in a single chunk. And there's no way to optimize that because if you think about it, there is no way to actually reduce the vertice size. I've tried by using quads and thinking like, well, right now we're duplicating the vertices per triangle that's using it, so we're not using shared vertices. And I thought like, okay, then I'll just make it use shared vertices. Well, that comes into an issue where the normals end up getting smooth. The only way to have hard faces where it's sharp corners is by not sharing the vertices. You have to make the vertices their own vertice per triangle, basically. And it does suck to have to do that, but there's not really a way around it. Mesh dot set UVs. And this is going to be 0 for the channel, and then UVs. Recalculate normals, recalculate bounds, and mesh filter dot mesh is equal to mesh. Okay. So now we should be able to see if I just get rid of this gizmo stuff. Let's bring this back to 0, 0. Index is outside of the bounds of the array. Generate chunk. And then that's equal to that. So what part of this is saying that is my question. Chunk 88. Vertices.add IP. Voxel triangles. Oh. Shoot. Yeah, I think I know why. I'm actually positive I know why. It's because we need to get rid of this. We're not going to use P anymore. Instead, we're going to do 0. think we have 6 right here, right? Yeah, so 0, 1, 2, 2, 1, 3. Then UVs is also not going to be P. This is going to be 0, 1, 2, 2, 1, 3. Pretty sure. This is now going to be plus equals 6. Oh. Something's happening? It's not that it's inside out. Huh. Vertex index plus 1 plus 2 plus 2 plus 1 and 3. I'm just curious why it's generating like that. Because it's skipping it's doing the bottom one. But it's not doing the top. But yeah, again, it's just not that it's inside out or anything. It's just not rendering it at all. Um, this is also going to take a vector3 int for local voxel pause. New vector3 int x, y, z. And we're going to add that to the end here. So it's going to be 0. And then 1, and then 2, and then 2, 1, 3. Oh. Yeah, no, I see why I did that. Because triangles should just be +1 +2 +3 +4 +5. There we go. Yep. And I don't know exactly what causes that like weird shading thing on the top. But I mean, I think it even does it with the default cube. Yeah. So it's just a Unity thing. Something to do with the way it calculates lighting. Might be a Unity 6 thing, to be honest. But now, what we could do is do a really quick texture. As a matter of fact, I just had one there. This one, we're going to save it. Just put it in here. And then we could see what it looks like with this. Looks good. Inside's not being rendered. And then one thing we could do to check this whole thing is set this to 1. And now you see how it's like broken like that? The reason is because it ran out of vertices. So it can't actually fill the rest. I can't really show you that, I don't think. Yeah, no. But trust me, it's because it's out of vertices. We can check like this. It's because every inside face is being rendered. So that's where the next thing comes in handy. We're going to do something like this. We're going to do voxel normals. This is going to be a vector 3 with 6 of them. Vector 3. And then this is going to be back. Forward. Right. Left. Up. Down. And then we can actually call this vector 3 int. It's going to be the same exact thing. Then in this, we want to do, actually we'll leave that there. But the top here, we're going to want to continue if voxel mesh data dot voxel normals. I misspelled that. Normals. With the index of I plus local voxel pause. And then we'll do get voxel. Equals 0 or does not equal 0, then continue. What that's going to do is if the block is anything but air, just skip rendering it. So what that should do is now be a hollow thing. Now you can see the whole thing is rendered, and if we go on the inside, you can see it's now empty. All those faces are no longer being rendered. Which also means we can now come up to populate voxel map, and we could do something like float noise is equal to mathf dot Perlin noise xz, and we'll multiply that with 0.03 just to scale it in. Is less than 0.5 f. And this is going to be bool. Actually, no, float noise is equal to that. And then we'll do voxel map of this is equal to y is less than noise. Times 16. And if it is, then 1, else 0. What? There we go. Actually, wait a minute. No, we want to multiply this by 15. Here in a couple minutes, I'm going to have to let the dog out. Now look at that. Completely not rendering the inside, but it's rendering the outsides because there are no chunks. But if there were chunks, it would use the chunks to try to calculate if it was connected to something. If we look, we got that. It does have smoothness on the material, but I could turn that off. We can make it super smooth. Yeah, it's like a metal. So like when it's raining in the game, you could make it like this material. Then you could even add some UV or some normal maps to give it some depth, kind of. Like if I go and I make a new layer of this, and then we turn the saturation all the way down. Then bring that up, and we'll bring it up a little more. Just like that. Then we'll save this as a height map. Grass height. We'll also do that and that. You can also turn this off. Then real quick, we could just do like a little shader. We'll do lit, I guess. Block shader. Then texture 2D main text. This is going to be our block texture. Sampler 2D. It's going to go right in there. And then we'll have our height map. Sample, and then normal from height. This will get the grass height. That'll go there. Now we just drag this onto there. Ooh. I don't know what's going on there. Tangent world space, maybe? I think I just need to clamp it, to be honest. Clamp. Normal. And then we'll have a float for smoothness. This is going to be in the range of 0 to 1. Then a normal strength, which is again going to be 0 to 1. This one is going to be defaulting at 0.01 though. So there's that, and then we'll have a float for metallic slider. Okay. Why is it doing that though? Tangent world space. Normal from height. So I'm going to see if I increase this. I just don't know why the sides are like that. It's just east and west. Huh. I wonder if I go in here and then I also add a private list of vector 3s, which is going to be normals. We remove that, And we do mesh dot set normals. Normals. And then down here we'll do normals dot add. We'll add 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I don't think that's going to change anything. Oh, shoot, wait. Yeah, that's not true. This is going to be I. 2, 4, and 6. Reason it's going to be I is because that's the face, and so that's the normal of that vertice. Yeah, there we go. So now we're not recalculating normals either. However, this normal from height is not really working too well. Normal, wait, no. Default. Yeah, I'm just not really understanding this. It's like, it's fine like that. Normal from texture. And then what color is... I mean, I guess I could use a normal map generator. The only reason I didn't want to is because they don't really work for large or small scale textures. But I guess what I could do is resize this and we'll scale it to like times 16, right? It'll be 256. 512 will work. And then here we're actually going to do normal from texture. Actually, wait. Why can't I just do like texture 2D normal map sampler normal? Something like that. And then if I drag this height map, Oh, that is the height map. Normal map. Switches to normal. Then I should be able to bring this up, right? Gosh dang it. Normal from texture. Normal map. Normal strength. Normal map. Hopefully that works. I don't think it is working. Offset? Wait. I'm really confused about this, to be honest. I think I just put it there. And then we switch this out. We'll just go back to URP and lit. Then we have our normal map. Then I can adjust the scale from here. So like 0.5 or 1 again. So now if it's wet, that's what it'll look like. And if it's metal, it'll look like this. Wet metal. I wonder if I actually bring this back to bilinear. And then I maybe blur that. Bring this back into Unity. This will be the new normal. Whoa. Oh, there we go. So now if I put this to like 5 or whatever, you'll see it's like not nearly as bad. And then I should be able to do an occlusion map. I might just do like a super simple occlusion to where, let's say I do occlusion. This will be resized to like 512 by 512. And then draw shape. Fuck. It is taking forever. Okay. So now I just like connected colors. Something like that, maybe? So now we got that. Oh, you know what? Because they're connected, that occlusion is not going to work. I didn't think about that. So yeah, let's get rid of occlusion. And then we have the metallic map and the height map. The height map we have right here. Which really isn't going to like do much for us. Yeah. So yeah, I guess the normal is all we got. So next, I think I'll want to add some like sort of placing blocks or something. I'll just add like a free cam and then we'll work on placing and breaking blocks so that we could like, we'll make it so when we place a block on the edge of a chunk, it'll create another chunk dynamically. And then we'll just start building into that chunk. Instead of having like the player generate chunks as he walks around, because that's kind of pointless for how we're doing it at least. All right. I'll be right back because I gotta go let the dog out. And I'm back. Okay. Just so you can see, this is what I used for generating the normal map. This website right here. I basically put in the height map, or what you could do is generate different lighting versions of your texture. So, like, as you can see, this is the same texture, but in Blender or something, you would like cast. Okay, so in Blender, it's kind of hard to describe. You would generate a texture with the lighting property, like facing different directions, and then you'd like make the normal map with that. But yeah, this is what we basically just generated. And like I can adjust the displacement. Obviously, we're not using displacement, so I can set it to like 0, and that'd be the same as what we're doing. Turn off rotation. And then let's look at a brighter side like this. You can see I use the strength. It was at like 2.5 when I first started, so I increased it and then I like brought it a little bit down. Blur and sharpening was up to 0, I think. And you can see how hard that is. So I wanted to bring it down. Filter doesn't really matter, I don't think. Yeah, I definitely don't like that one. It's got like weird lines. But like I can make it real sharp like that. Or it's just the issue with it being sharp is that because the pixels are the way the pixels are, like it's just too sharp, I guess. The hell. I can invert it if I wanted to. I could do Z range. I don't know what that does. I could even load a model, but obviously we're working with a cube right now, so that's all we really need. But yeah, that's what I used. And then I used Blockbench, obviously, to create the texture itself. So, like, what I'll do is I'll go back, and I'll set this back to 16 again. And you could do this in literally any image editor, pretty much, any free online one or whatever. Just take your texture, grayscale it, and then increase the brightness until the widest pixel is not like, or until the second widest pixel is not white, pretty much. Like, so when you brighten it, you're going to get to the point where everything just becomes white because you're just lightening every pixel, but there's no such thing as past white. So it's just like everything's going to, you want to get it to the point where everything is bright, but you're not losing detail by making it so bright that you're that the second brightest color is also white, you know. It's like right before it gets white as well. So you just do that, and then that's your height map pretty much. Technically, that's not a really good way for these textures to do a height map, because let's say I had grass like this, and then I had like brown in the bottom, because this would be the side of a dirt block or grass block. That wouldn't work then, because it would do the same exact thing, and it almost look the identical, honestly, when it comes to the height map. Maybe a little different, but for the most part, I'd have to go in and manually like do the height differences. But with that being done, we can now do another script. This one's going to be called FreeCam. FreeCam. And we're going to just, this is going to be a mono behavior because we're going to put this on the camera. So we'll do public float sensitivity. Put that to like 1,000, I guess. Public. Do I need anything else really? No. So private float x rotation is equal to 0f. This is so that we can clamp our x rotation because x is up and down. We want to be able to clamp it when it hits 90 or negative 90 because if we don't, then we're going to be able to like flip our camera all the way to where we're now upside down and stuff. And I don't want to be able to do that. And then, so in update, what we're going to do is float mouse x is equal to input dot get axis. We're literally going to call this mouse y times sensitivity times time dot delta time. Time dot delta time is the amount of time that the last frame took to render. So it's like an approximate way of being like our sensitivity is like this is how much we're going to be able to move per second. If I'm moving the mouse at 1 pixel per second and this was 1,000, then this is going to be 1,000 pixels per second, which if you think about it is like if I'm looking at a 1440p monitor, then 1440 is going to be on the height. So that'd be 14 seconds to be able to get all the way up and down if I was moving at 1 pixel per second with the cursor. Obviously, I'm gonna be moving more than that because like how fast I'm moving right now is faster, but you know. So time dot delta time is just to be able to make sure that no matter how many frames are being rendered, if I'm getting 60 FPS or 120 FPS, that gives me a scaling factor to make sure that it's smooth depending on my frame rate. So no matter what my frame rate is, it's still going to be like consistent. Oh yeah. Also, this is going to be X rotation, and this is going to be Y rotation. Or no. That is mouse X, mouse Y. This is actually mouse X. This is mouse Y. Do the same thing here. Then X rotation minus equals mouse Y. Because if you think about it, mouse Y is up and down. And since our X rotation is up and down, so we're going to subtract that from the current X rotation so that we can then clamp it between negative 90 and 90F. And then we'll just do transform dot local rotation is equal to quaternion dot Euler X rotation, and then this right here will be private float Y rotation is 0, and then we'll also do Y rotation plus equals mouse X. Then we'll do Y rotation. We don't need to clamp the Y rotation though. Then we'll come to our camera and then we'll drag FreeCam onto it. Now we should be able to move around our camera. So now if I look like that, let's actually bring this to like 0 and then negative 16, maybe. Yeah. So there we go. We can now look around perfectly fine. Everything feels perfect. Now we want to be able to fly around. So then we want to do public float slow speed equals probably like 4F. Public float fast speed equals 10F. And then if input dot get key down, and then we'll do key code dot. Actually, we'll do input dot get mouse button, and that'll be 1. So that's right click. Then slow speed or fast speed plus equals input dot get or input dot mouse scroll delta dot, what is this? Dot y? There should only be dot get axis scroll wheel. Let me go and look at, what is it, project settings, then input manager. Mouse scroll wheel is the thing that we're looking for. So mouse scroll wheel times time dot delta time. And then fast speed equals mathf.clamp fast speed between slow speed and mathf.infinity. We'll put this in here since that's the only time it'll change. And we'll just do this. Just so that we're not setting a bunch of variables at random times, you know. And then, or at every single frame, you know, because like a lot of these things are not going to be changing. And then we're also going to do float movement, or actually this is going to be a vector 3. Vector 3 movement is equal to vector 3 dot forward times input dot get axis. This is going to be vertical plus vector 3 dot right times input dot get axis horizontal. And then float speed is equal to input dot get axis, or actually input dot get key down. This will be left control. Then we will do fast speed, else slow speed. And then we'll do, this is actually going to be transform.forward and transform.right, because that basically means forward on the way that this object is facing, and since this code's running on the camera, it's like wherever the forward direction on the camera is, multiply that by the vertical vector or axis of the input manager, which is WASD or the arrow keys by default. And so basically if I press W or S, that is vertical. So W being 1 and S being -1. So if I press both of them at the same time, that'll be 0. If I press W, this is going to be 1, so it's going to be 1 times transform.forward, and with the way it's currently set up, transform.forward is plus on the Z, so that would move me 1 on the Z. This would move me 1 on the right if I press forward and right at the same time. And then we're going to multiply the speed with the movement and time.delta time. So we'll do transform.position is equal to, actually we'll do plus equals movement times time.delta time times speed. And like it's suggesting, we're going to reorder this. Reason is it's actually faster to multiply a vector 3, or it's slower to multiply a vector 3 since that's 3 multiplications than it is to do these. So instead, since they're all being multiplied together, it doesn't actually matter what order, but for the speed's sake and performance sake, you want to multiply all your floats together, so then you can multiply that with the vector 3 at the end. And if I had a vector 4, the same thing is like try to multiply it at the end if possible, just so you're not multiplying a vector 3 by like vector 3 times speed, vector 3 times time delta time, you know. But just like that, that should be a working movement script now. I'm going to turn this up to 100 just to see. Yeah, this is supposed to be get key, not get key down. Also, I am going to multiply this with like 10F. Reason being, the speed it was at right there was way too slow. Even that's too slow. I mean, I want to do like 100 or maybe even 1,000, because it's doing like 1,000th of a percent per second. There we go. Now, if I full screen this, it should be a lot smoother. And if I slow myself down, so that's super speed. This is regular speed. Okay, and then we'll do another script. This is gonna be called block highlights. We'll also put this on the camera, but we're gonna get a cube. This cube is going to be called place highlight. Put it at 0, 0. We'll duplicate it. And we'll do destroy highlight. And then both of these need their own materials. So place destroy. Destroy is going to be red with a smoothness of 0. And actually, an opacity of that, we'll do transparent. Transparent. This one will be green. 90 on both. 90. Receive shadows off. Receive shadows off. We'll actually switch this out to unlit. Same with this. Unlit. Okay. Then destroy goes on destroy. And place goes on place. So destroy needs to be a little bit bigger than a regular block. So like 1.05 or something. Maybe even smaller than that, like 1.01. So that's our two different colors. Then camera, we're going to add another script to it. Wait, actually, block highlights. Let's do public transform place highlight. Public transform destroy highlight. Then on update, we're going to do well, this is also going to need a public dimension. It's going to do here, let's go to here. And get voxel, and then we'll also do does voxel exist? Get chunk. Return chord. Or actually return chunk. This is going to be a chunk. No, this is going to be... Actually, no. What am I doing? Return true. Return false. Then this is going to be a bool. Chunk loaded. Is chunk loaded. Then we'll do vector3 int local voxel pause is equal to now this is the issue, is because I'm going to need a while loop on this one. So while, and we'll do float distance is equal to 0.01f. Float max ray step or step size equals 0.1f. Zero point zero one f. Float range equals 10f. Public float range equals 10f. then this is actually going to equal 0. Well, distance is less than range. Or less than or equal to range. Distance plus equals step size. So last distance. Actually, we'll just subtract it. So just trying to think, how's this gonna work? I want to get the hit normal, but I don't think I'm gonna be able to do that. Where'd my things go? There they are. Yeah, because I'm not using actual raycasts. If I were to use raycasts, then it's like, honestly, I should and shouldn't use raycasts because I'm probably going to be using. It'd probably be more efficient. I'll just say that. Possibly. I mean, this is basically a raycast. I just think a raycast would probably be way more likely to actually hit. But the way that we're doing this is going to be searching through the actual voxel array. And so we're going to do voxel or vector3 int local or global voxel pos is equal to transform.forward times distance plus transform.position. And then we'll surround this in those and do vector3 int dot floor to int. Yeah. And then if dimension dot get chunk or is chunk loaded global voxel pos, then break. Global voxel pos is equal to transform.position. Vector3 int dot floor to int. Then here we'll do that. So is equal to that. If dimension dot get voxel global voxel pos does not equal 0, then we'll break. Vector 3 int new voxel pause is equal to this if new voxel pause does not equal global voxel pause and continue. Can I continue in a while loop? I can. Actually, I don't really care about that. We'll just do new voxel pause. Last voxel pause. And then down here, we'll do we'll hit equals false, hit equals true. At the very end, we'll do place highlight dot set active dot game object dot set active hit and destroy highlight dot set active hit. So then we'll do place highlight dot position is equal to old or last voxel pause and destroy highlight dot position is equal to new voxel pause. Now let's go ahead and put this on our camera. Block highlights. I can get it on here. Then we got our dimension, destroy highlight, and our place highlight. Oh, weird. New voxel pause. Where is it saying it though? Dimension at 38. This is supposed to be floor. What am I doing? That was pretty stupid. Seal is going to round up, whereas floor is going to round down. That's putting them both inside of each other though. plus new vector 3 0.5f. Then I could probably even add that to this. And then just for testing purposes, let's add a UI crosshair. I'll just do image. Make this like 2 pixels by 10 pixels, like 16 pixels. Put it right in the center. Make it black. Reduce this to like 90, maybe 120. Okay, maybe up a little more. 170 works. Duplicate. Let's make it 16 by 2. Now we got a crosshair. Yeah, so let's not add 0.5 to this then. That's a lot better. However, it's still not putting the place one on the correct spot. So let's try to see new vector 3. This is actually supposed to be backwards, so place is going to be... Oh, wait, no. That is right. Oh, shoot. No, the reason is because we're setting that there, when instead that should be there. That should work. Yep. So red means break, green means place. Like, that's where the block would be placed. technically you could get a bunch of issues with like trying to place right in the middle here. Notice how it's now clipping through a block, which isn't necessarily correct, but that's because the distances. And the only way to fix that would be using raycasts with collisions. But let's go ahead and just do something real quick. So let's do public void edit voxel vector 3 and global voxel pause, and the byte for voxel ID. And then we'll do is chunk loaded global voxel pause, because if it is, if, then we'll run some code. Or actually we'll do if not, then just return. Actually we'll return, but we're also going to throw Can we throw anything? No. Return new exception. New invalid chunk exception. I don't know. Exception dot. I don't know how that works. Whatever. We'll just debug.log or log error. Chunk does not exist. Failed to edit voxel. I'm only doing that so that we know, because we don't actually want to ever call edit voxel unless we know for a fact that the voxel already exists, but technically I don't want to, yeah, I mean, regardless. Anyways, we're going to do this right here. And then chunk dot edit voxel. And then we'll get this. Local voxel pause with voxel ID. Then public void edit voxel pause. Call this local voxel pause, because that's what we're expecting here. And then if this means it's outside of the chunk, then return. But we also want to debug.log error failed to edit voxel local voxel pause is outside of chunk bounds. And then here we'll do voxel map of local voxel pause.x is equal to, then we'll do byte voxel ID. Voxel ID. And then we'll do vertices dot clear, triangles dot clear, UVs dot clear, normals dot clear, and vertex index is equal to 0. Then we'll do populate mesh data and build mesh data. And then dimension dot edit voxel. Actually, if input get mouse button down, and that's going to be left click, so that's going to be destroy. So then we'll do dimension dot edit voxel. New voxel pause, and this will be 0. If that one, then dimension dot edit voxel, new voxel pause, and right now we only have one block type, so we'll just do 1. So now if I break a block, it breaks, and if I I have to do last voxel pause. Failed to edit voxel, chunk does not exist. That's good. Good that it's saying that. I should say it when I try to place up here too. Yep. Oh, what did I just do? Okay, so we got that. And the reason why this is not working is because it does not exist. And so actually what I need to do here is that. And then right here, what I'll instead do is create chunk or generate chunk. Chunk chord. Or this is chord. And this will also take in a byte array voxel map is equal to null. If voxel map does not equal null, then we'll do chunk dot voxel map is equal to voxel map. It's inaccessible, true. So Oh, wait. I'll just do voxel map. And over here, we will do byte array voxel map is equal to new byte array 16, 16, 16, and voxel map of local voxelpos.x, local voxelpos.y, local voxelpos.z is equal to voxel ID. And chord as well as voxel map. Then I'll have to pretty much update the chunks. Right now they're not updating the side chunks. What I mean by that is if I place this right here, see it actually placed, which means now there's two chunks, as you can see, one with a single mesh in it, single voxel mesh. But if I go in here, you'll see the face is still rendering on the inside on this chunk, which it shouldn't be. But if I were to, let's say, break this one, you'll see it updates then. So edit voxel. And we'll have a public void update chunk or update mesh, which is just going to call both of these. Then we'll do update mesh. And then down here we had something that was doing it. So update mesh. And then this one is going to be edit voxel. Here it's going to need to know the neighboring chunk. So chord if local voxelpos.x, or actually, how do I just get the direction? That's all I want right now. Because, like, if it's 0, I don't want to do a bunch of if statements to check each coordinate. So how could I get just the direction in which that this is next to, like, what edge is this neighboring? I'm not really sure. So we have our local voxel pos, which is going to be in the range of 0 to 15. And if it is 15, then that means we need to update the right or the front chunk. if it's 0, and I don't want to update all 4 neighbors. I guess technically 6 neighbors. I don't want to do that. I guess I could just make a function to handle it. I could do private vector3 int get neighbor chunk chords, and then we'll just pass in vector3 int local voxel pause. Or actually, we'll just do global. This is actually going to pass, or this is going to return an array of them. List of vector3 ints. We're going to call this neighbor chords is equal to new list. Then we want to do this. If local voxelpause.x is equal to 0, then we want to add neighbor chords.add chord plus new vector3. Actually, we'll do vector3 int dot back, or left. Copy that. It's equal to 15. This will be right. It'll be y and z. Y and z. So y, we want to do down, up. This will be back, forward. And then return neighbor chords. And then we'll just have this return a list instead. Vector3 int. This is going to be a list. Neighbors to update equals get neighbor trunk chord. Then for each neighbors to update. Oh, very chord. Very C in neighbors to update. Then we'll do C dot update. Oh wait. Then we'll do chunks dot try get value. C out ch or out chunk c8. Let's do out underscore chunk. What? Oh. If and underscore chunk dot update mesh. We'll actually just get rid of that whole thing. Okay. Now I want to place one right here. Didn't work. But now it did. And then if I break these, you can see it's back. Break that, it's back. Break that, it's back. I mean, it's working. I do want to fix the camera thing, though. Let's go into our free cam and let's go in awake. Let's do cursor dot lock state is locked, cursor dot visible equals false. Now you can see it's generating chunks as it needs them. Perfect. Then I also want to come down here into the chunk class, and we also want to add a private mesh collider. And I know this is going to be a lot laggier and it needs to be, but I don't think the scenes will be big enough to where it really hinders performance that much. Because I think in-game, since this is going to be like mini games, I don't think I'm going to have destruction of voxels if it's in like the actual mini game. They're going to be like static maps. Maybe I'll add destruction of voxels, but I'm not sure because I'd have to find a way to do better performance on the destruction. Because like right now, if we do a little performance test, we'll probably see a big spike in FPS drop when we do this. Also, really quick before I do that, let's update this and let's do vector 3 vertical movement equals vector 3.0 vertical movement plus equals plus equals new vector 3 0f. Actually, we'll just do dot y plus equals. Can I do that? I can. Okay. Input dot get axis or get key, and then we'll do key code dot left shift. Then we'll do speed. We'll do slow speed, I guess. Slow speed. Times time dot delta time times -1. Else 0f. Or else actually, let's do this. We'll do if that, then we'll do movement dot y minus equals slow. I guess we could have speed up here, right? Only reason I didn't want to use the speed is because we're probably not going to be able to press control at the same time as shift. Easily, at least. Speed times time dot delta time. If input dot space, then this is going to be plus equals that. And we can clean up our code a little bit. Get rid of this whole vertical movement thing. Because we just added it directly into movement. Now I should be able to move up and down pretty easily. Wait a minute. Why is it so slow, though? Speed times time dot delta time. Not normalized. Ah, because of speed. Wonder if it's just minus equals time dot delta time. We're multiplying by speed twice. Okay, now there's like an input delay. Dude, get access raw because that was causing it to, it was interpolating from 0 to 1 when I let go, and since it was doing that, it was like keeping the movement. It wasn't slower because it was normalized. There we go. Although, for some reason, it's not doing, oh. Let's actually do float vertical movement equals 0f. Then we'll do vertical movement because I need to multiply. And then we'll add vertical movement times what is it going to transform dot up. We'll actually do movement plus equals that. And then it'll be normalized there. There we go. Oh no, that's not what I wanted. I guess it is just movement dot y plus equals that. Yeah, I'm not quite sure why it's not working when I am going in multiple directions. Like if I'm holding W and then space, it's not actually seeming to go up and forward. Yeah, I'm doing it right now. It's just not doing anything. But I let go of W and then it works. It's kind of weird. Okay, but they do have mesh colliders now. No, they don't. I thought they did, but I forgot to actually add the code for it. So let me go ahead and do mesh collider dot shared mesh is equal to mesh. Then I need to come up here and do mesh collider is equal to chunk object dot add component. And then saving the voxels or like the chunks is actually pretty easy. But now we can check the FPS and just see what it's like. So we're getting like 250, 260. Yeah, look at that. It drops like 50 FPS, sometimes even more. Dropping like 60 to 70 FPS. Just by placing. I am spamming right click, so that's like a lot of placing, but even if I just like do it just by clicking fast, it's like dropping like 20 frames. I'm gonna go ahead and do a debug screen. Public game object debug screen update if input dot get key down keycode dot F3, I guess. That's just what Minecraft does. Then I'll do debug screen dot set active, not debug screen dot active self. So that'll toggle it. And then if debug screen dot active self, if not, then we'll just return. Public float frames or FPS equals 0f. We'll actually do public float time equals 0f. And public int frame count equals 0. Time plus equals time dot delta time. Then frame count plus plus. Then public TMP text will do FPS text FPS text dot text is equal to FPS and then we'll do what is it, 60 divided by 1, so frame count divided by time. And honestly, I could probably just do time dot time. And then we'll get rid of this whole time thing. No point in keeping track of that if it already exists. Then we'll add a debug screen game object, which is going to take up the whole screen. And then we'll do UI, we'll do a text mesh pro. Then FPS 165. We'll just put that there. And also a UI panel, which will also be on that side. We'll do like 50, maybe like 190. Make this black. Like that. Get rid of that. And then we'll do vertical layout. control the width, but not the height. We'll do like 15 spacing, and then we'll do 15 or 5. 5, 5, and 5. So there's our FPS. Then we'll put that on here. Debug screen goes there. FPS goes there. So if I press F3, I don't know why it's just going up like that. But now it's going down. What the fuck is happening here? Oh, that's the canvas. Okay, well, it's not even accurate to this. Oh, shit. Oh my gosh, look how much it goes down. My FPS drops by a half. Just by displaying that FPS. Oh my gosh. There, I'm a look in chat GPT. How to calculate FPS in Unity. I think that's right. I mean, I see. I could do that. So, average frames. So we'll just do like 60 frames. We'll average. Frame count. So this is kind of what I was doing. Get rid of that. And just throw an FPS there. I want to see how much this drops my performance too. Oh, but not really. That's pretty accurate. I wonder if I turn on VSync. Let's go to free cam and let's do. I don't know how to turn on application.vsync. Vertical sync. quality settings dot vertical vsync count equals 1. And then I need to go to product setting. I've never turned this on because I thought it was always on. Project settings. And then quality. We're on PC right now. VSync count. Every view blank. Oh, and then I need to turn this on. I mean, I'll be honest, it's definitely not working, but I don't know why. Let's turn this back to this. Let's do 0.5. I mean, it's got to be like 160. I mean, it's hitting more than my thing, so I don't know exactly why. Display. Weird. What the fuck? Whoa. That's all for something. So that's the shadow map, blit color. This is normal. This is something to do with ambient occlusion, it looks like. It's really cool. Then we get our opaque objects. Then we get our skybox. Then we copy color. Then the bloom. RG Uber post. Whoa. Space UI. UI is the last one. Okay. That's cool. I didn't know it had that. Well, I mean, almost every engine, I'm pretty sure, has something similar to that. But that's very in-depth, which I really like. Normally, I see people like Acerola using a separate program to do that. The one specific example being uh Lethal Company, when he was trying to like figure out what they were doing. Okay, so it's definitely laggy. However, I think the reason why is because I only want this to, so public list of chunks to update equals new list. Then we'll do fixed update. Public or private rule is updating chunks equals false if is not updating chunks and chunks to update dot count is greater than 1 or greater than 0, then is updating chunks equals true. Actually, we don't even need is updating chunks because we're not using a loop. Like a loop that's not going to be in a single frame. This is going to handle in a single frame, so we're going to do for int I is equal to 0. Actually, we'll just do for each in chunks to update, then chunk dot update mesh. Then at the very end, we'll do chunks to update dot clear. Then down here in edit voxel, we're going to do anywhere I'm calling update mesh. We're actually going to put that in chunks to update dot add chunk. Edit voxel. Then instead of that, we're going to do dimension dot chunks to update dot add this. There. Now technically, it should be on a tick rate now. We're actually updating the mesh as opposed to how it was doing it before. Yep, now it doesn't look like it's nearly as bad with the FPS drops. Like occasionally you'll see a FPS drop, but that's on the tick interval rather than constantly happening. Ooh. But I'm still able to place the voxels because, well, just because. One thing I would like to do is possibly even, instead of on fixed update, maybe we make another loop. And this will be a private IE numerator. And call this chunk update loop. And then, well, true. Do that, and then we will yield return new, wait for seconds, then 1f divided by our update. So how often is Unity's fixed update? It's 50 times per second. We want it to be 20 frames, so oh wait. I actually want to just test this because now it shouldn't actually update the mesh. Yep. So it is on the new generation, which is fine. But you can see the voxels are there. It's just the mesh isn't being drawn. So I'm not getting those lag spikes right now. And then instead of here, we're going to do start coroutine chunk update loop. Yeah, and you can't even notice that it's happening. But if I decrease this, let's do like every 5 frames per second. That was honestly pretty good speed where it was at. Even that's not like horrible. Like it lags behind just a little bit, but like let's do like, because that's 5 times per second. Let's just do one every 0.5 seconds. And actually, what I'm going to do is do a public float here. Public float. This is going to be update tick rate equals 1f. Actually, just set this to 20F for now as the default. Then we'll put this to like 0.1. So it's every 10 seconds. And then I'm also going to modify some other stuff. Yep. So now like 0.5. So now what I want to do is we're going to hold off on when we generate this. We're no longer going to update the mesh immediately. We're instead going to go to dimension dot chunks to update dot add this. And then we'll keep it at 20 for the update speed. Could probably even do like 10. Actually, what we'll do is we're going to add a boolean here. Public bool insta break insta speed, or actually click rates. It's false. Just set it to true, I guess. If click rates else, it's literally the same code, except for this one is going to be get button instead. And honestly, I'd like to put this in fixed update, but the issue is it's just not efficient in fixed update because it won't, like, if I were to do the single clicks, it wouldn't pick up the clicks. Like, the odds of me clicking on one of the fixed update ticks is just pretty slow. Wait a minute. Why is that not like... Oh. So now I'm pretty sure it's doing this like lagging because of the... It's not the mesh. It's because of the step size, which I don't really want to turn down or turn up. But like... 0.2 maybe. Like, I mean, I could even shorten the range, but it's just because I'm in a while loop on this. But I do want it to happen in this frame. So it's going to have to be either a while loop or a for loop, but it's not going to be any more efficient either way. Yeah, see, that's already so much better. Oh, wait. I mean, maybe it feels a little better, but it's still not good. It gets laggy as hell doing that. So I guess for that, what I could do is public void fixed update, click rates, return, and then if not click rates, return. Which then means I can just pull this out. And we'll copy literally everything inside of here. Except for this, I'm going to get rid of. And this one, I'll get rid of this. The reason for that is just because fixed update will work for the other one, for the get button, but it's just not going to work if it's like the actual like individual clicks. So now if I check, still somewhat good. And click. If I turn this down, a lot better. Still not great, but again, it's just that while loop. Shit, I didn't mean to break them all. Anyways, that's working fairly well. So now, I mean, I could add multiple block types now. I could possibly even swap out from a byte to being like, I guess the byte could still be used because then each chunk could have its own palette of colors. How do I want to do it though? Because if I do that, then it's going to dramatically change when it comes to the voxel map. Because like this voxel map's gonna have to be like, well, no, the yeah, the voxel map will have to change. No. The voxel map will stay the same. And all of this stuff is going to stay the same. The only thing that changes is the scale. So this would be like X there and then Y. Well, this is if I'm doing smaller voxels though. Then the whole, like a lot of code will change. Like this would change because this would actually be like 8. Oh god, all the collision checks would change. That's where ray casting would probably just come in handy. And as a matter of fact, it might be worth switching over to raycast instead of a while loop. It's going to be more consistent, as well as it'll be more friendly, I guess, on FPS. I guess let's just try it with that then. So let's separate this out. Let's do void old block handling. And then in here, we're going to do if, well, actually, no, because we need a raycast anyways. So raycast hit. No, we're not going to do that either. If physics dot raycast transform dot position transform dot forward range and then I'll check if it has the correct tag. So over here we will want to add the tag to this object. So chunk object dot tag is equal to chunk which also means I have to add it in here. Chunk and then I'll do out. Actually, I think I have to out right here. Out raycast hit if hit dot collider dot tag or compare tag chunk then I'll run some code. So vector3 int, this is going to be destroy pause is equal to hit dot point plus transform dot forward times 0.01f. Then we'll do vector3 int dot floor to int. Then I'll do the same thing right here. Destroy pause, place pause. But subtract. And then we'll do this. Destroy, place. Then place, destroy. Then what else? Cool. Hit equals false. Hit chunk equals false. Hit chunk equals true. And I'll paste these down here. Void new block handling. Public bool use old handling. Close false. If use old handling, then old block handling, else new block handling. And we'll just see how this works. It's doing that. Both of these need to get their colliders taken off. So now, one issue we were having before was if we looked in, oh, it still does it. So we're getting like 270. The occasional spike. It drops down to like 240 when I do that. Let's switch this out. 270. About, it seems to be dipping under 270 a little more. $240. I think it's about the same, to be honest. So we'll use new block handling. So void handle block interaction. And then we'll do vector3 int place pause, vector3 int destroy pause. Then if click rates else single click. Then right here we'll do handle block interaction with place pause and destroy pause. We'll take this out, put it in update. Yeah. Because I guess we're not using the while loop anymore. Although yeah. So then we can get rid of fixed update. I like having it in fixed update because it is a lot slower, but when it comes to single clicks, it's just, I don't really know how to handle it. I mean, I know how to, I don't want to. Like, it's a pain just to do that. We'll see though. Depends on how laggy it gets. So let's switch this out. Oh, wait. No, that's pretty laggy. So then maybe we do put it in fixed update or something. Update. I'm gonna ask ChatGPT, how should I handle get mouse button down when using fixed update? It seems to not register sometimes. Detect input in update and process in fixed update. Okay. So private bool destroy rest is false. Private bool place pressed equals false. Ooh. Fixed update. Then I'll take all this. Actually, we'll keep that there. Just for now. And then here we're gonna, if we're on single click, then this is destroy pressed equals true. Place pressed equals true. Place if destroy pressed, if place pressed, destroy pressed, place pressed. And at the very end here, we'll do destroy pressed equals false, place pressed equals false. So it's on single click right now. So let's see how it works. Oh, what the hell? I think it's considering control as a place. Maybe. Then let's do that. Way smoother. But honestly, I kind of want to take the update tick rate, add it up here. Then we'll get rid of this, i.e. numerator. Highlight loop, I guess. All true. Add all that code and then yield return new wait for seconds 1f divided by update tick rate. And awake. Or I guess I could do start. Nope. Void start. And start coroutine. Highlight loop. Actually, we have the dimension here, so I could just use that. So I'll do dimension update tick rate. Then it's on the same. It's not going to be running on the same tick. I don't think. It might be a little bit off, but at this it's running on the same speeds. But now I should be able to place 20 blocks a second. And break. Way faster. I mean, obviously I'm not breaking like a million blocks a second now, but still, it's just like considerably faster on FPS wise. And it's way more stable. I see 270 right now, not doing anything. I start breaking blocks and it's like 230s, 240s. Occasionally it dips below, but yeah. Still pretty good. And honestly, I think I do want to change it though. Just because of the fact that I want less blocks. Like, we really don't need it to be that fast. Maybe do like 5 blocks per second or something. This is without any threading. Although I don't know what I would even implement threading for, because I'm not really generating... Oh, yeah, that control thing. Oh, you know what? I think in late update... Destroy pressed equals false, and place pressed equals false. Maybe that'll work. It's because I think... Oh, maybe... I don't know. It's when I click into this screen. That counts as a click, and it's saving that until I get next to that chunk. Watch. Okay, it didn't do it that time, but... But now it's like... Not even, like, letting me do anything. So... Not sure. I'm 99% sure that the reason it's doing that, though, is because of... like, I just left click just there to get into the screen. So as soon as the game starts, I'm already in. But now I think it's detecting that I have clicked. So if I go over here, yep, see? So if I click, yeah. Let's also change this back up to 10. It's because in here, it's not checking if I'm pressing the block. So, I guess down here, what I need to do is if place pressed or destroy pressed, then we need to check this. Equals true, handle block interaction. We're gonna remove all this. And then do else. I'll actually just do that. Place pressed equals false. Destroy pressed equals false. So now what that's going to do is it's going to check for... It's going to shoot the raycast, check and see if I actually am hitting a block when I press the button. And then only then... Like if I didn't even hit a block or anything, then it's just going to ignore it. So now I clicked. Oh. Oh, that still didn't work. You know what? What I should do is... Shoot, then I'm shooting a raycast constantly, though. Whatever. Return. We'll return right here, actually. So I was getting, what, 270? I think it was. So let's just hope it stays there. A little bit. Yeah. It's about the same. But if I click right now, I'm not clicking, and then as soon as I look at it, it runs the thing. Damn. Actually, this doesn't even need to be in this single click thing. I'm just confused why it's not resetting, you know? If it does equal chunk, then we'll run that code. Oh. Fuck. I'll just say destroy pressed is equal to single click, then this, else this. Oh, else that. Then place pressed is equal to single click. With that, or that. Now we'll break this whole thing out of there. And then, honestly, I could probably just get it out of this entire thing anyways. Just do that. It might work. It was not resetting because I wasn't actually setting it to the input. Oh shoot, no, that's still not gonna work. I don't think. Yeah, see, I'm pressing it and it's just not doing it. If I change it to 20. Yeah, because I have to click on the tick. Damn. Wait, what? One place pressed and one. I don't think this is going to work either. Because if I press right now, fly up to it. Yeah. So I guess the only thing I could do is set this to 20. Well, even if I set it to 20 though, it still resets. So we'll just remove that whole part. K, C, no, Control K, U. Now, it just sucks because I'm not really sure. I don't think this is going to work either. I just clicked it again. But like I shouldn't have clicked on a chunk, so. Okay, it's not. I click, it does it. I hold it, it does nothing. If I click right there. Oh. But if I click really fast, click off, click, click, god damn it. So I clicked when I was looking at it, and I looked away. And if I fly over here, I'm not clicking. Notice how it clicked. Um, put this at the bottom here so that no matter what, it resets. This might fix it. I don't like the fact that I have to raycast to see if I'm hitting a chunk or the click, but click, clicked on the chunk. I think that fixed it. Yep. Obviously, it's all laggy just because of this. If I turn this up to like 60, then you'll see it's like instant. So now I have control over that, which is really nice. One thing I do want to do is swap this out. right there. And then we'll say if destroy pressed or place pressed, then we'll run this. And if this does not hit a chunk, then destroy pressed is equal to false, and place pressed is equal to false. And that should actually improve the performance quite a bit. Because now it's only going to raycast if I do click. Whereas before it was raycasting constantly. Well, okay, it's not going to improve the performance almost at all, but it's just like, I don't know. See, we're still getting like 270-ish. If I clicked while I was looking at it, and I look back and it's not clicked anymore. Perfect. I remove that. Now that is an issue where like that's not being updated when I generate a chunk. So generate chunk. We don't want to return. Instead, we'll do else. And delete that. And there we go. That should fix it. It's just because I was returning. I was also checking in the dictionary twice, basically, if the chunk existed. Which I didn't need to do. Right click. There we go. Updated. Let's turn on turn off single click. And actually, let's bring this back up to 20. Because that's where it's going to be at all times. So if I hold right click and I scroll up, probably use trigonometry to do that whole Bedrock Edition thing where, like, let's say I right click right here and I fly this way and I like look this way. You find the intersection point on that exact direction basically. So if I'm like looking over here, then it would like find the intersection on my facing angle to the position in that direction. But I'd have to get the normals and everything, and I don't want to do that. Just so I knew like what direction I'm facing or placing. Let's turn on or off single click. It's actually really smooth for right now. Because then I wouldn't have to raycast to figure out where I'm placing blocks, you know? I'd have to raycast the first one, but once I'm in that state of like knowing that I'm placing, it would be able to just figure it out. Like how far I'm placing blocks to. And this is actually infinite. This is already better than Minecraft. Like, look at this. I know in Minecraft it's like a 320 block height limit. This will generate chunks infinitely in any direct. Well, I wouldn't say infinitely, but until it hits the. Well, technically, yeah, it will generate infinitely. It's just that once I get to about 100,000 blocks, it'll throw an error in the console saying something about floating point errors. But I think it'll still work. So like, I mean, we're already taller in Minecraft world. We're at 800 units up in the sky. And I could turn this up to like save myself time on this. Turn this to like 120. Okay, that's not actually helping much. See, I can't even see the mesh down there. How many chunks do we have now? And this is with less chunks than Minecraft would have loaded. Just in a normal world. I think. This is 132 chunks. Whereas in Minecraft, let's do the math. a Minecraft world at a 16 render distance is 16 by 16. Well, actually, no, that's 16 render distance is really 32 plus the one in the middle. So 33 times 33. It's 1,000 chunks. However, I think Minecraft, and that's just horizontally. I'm doing my chunks in 16 by 16 by 16s. So technically that would be 3 times 33 times 33 times. I don't know how many I just said, but it's you do it 3 times. That'd be 35,000 chunks. And let's think about everyone if they had voxels, completely filling them. Times that by however many is in the thing, so 16 times 16 times 16. Now we're at 147 million voxels. Times that by the 36 for the amount of vertices. That's now 5,299,000,000 vertices that you would have. It's just so much. I mean, I don't think there's a single game that renders anything near that much. Like, notice we can't even see that stuff down there. It's so far. I don't know if it's being cold, though. It might be. Oh, yeah, it's definitely being cold. Okay. Then let's... fly up here. To the top of this. Oh, that's not what I want to do. I'm going to take my camera. Bring it up. Shit. There it is. Damn, I drug my camera so far. Okay, so I definitely can't see it from there. Let's go ahead and look and see if I could turn this up to like 10,000, 100,000. Right now we're at 2,000. I can't see the ground from this distance, but that's just because... I mean, yeah, I can actually. Turn it to 4K. Oh, I'm getting way more FPS. What? Almost 600. Yeah, see, I still see it from up here. I'm gonna turn my speed way up. Let's turn it to like 500. I just want to see. So all the way down here, we have this little mesh. And that goes all the way up. I do want to implement an LOD system though for standard voxels, because I'm definitely going to have like custom voxels, or at least support for them. And by voxels, I just mean block spaces. So like, because technically these aren't voxels. A voxel is just an area, and a cube is actually what's being placed in these areas. But the voxel is just like the byte array that I have, three-dimensional byte array. Where is it? Right here. The voxel map. That is a voxel. Each point in this map is a voxel. It's basically just saying like, hey, there's something here at this 3D location. And that's all a voxel means. So like you could have spheres in there, you could have rounded terrain that generates from your voxels. It's really up to you. I do want to get rid of this old chunk handling. Now I'm just trying to see. So, okay, so I'm trying to think. Let's pull up paint. Make it so we can actually see. So, okay, so this is what I was talking about with the Minecraft thing. So let's say we have our voxel right here. Or a block. This is the block face that we're going to be hitting. So, and by hitting, I mean we're going to start placing right here. So it's going to try to place a voxel right here. And let's say I keep holding right click, and I was looking at that area. So here's my camera. And then while holding right click, I fly over this way, and now I'm over here, and I'm looking over here. I want this to know that, like, hey, he was holding right here, and he clicked on this face of a block, so the normal is facing this direction. You need to fill in the lines all the way across until you get your voxel where he's now looking that matches that same direction from the normal straight across. The only issue is I don't know exactly how to calculate because in 3D space, we're going to have like these directions. These are our 3 directions. These being the negatives over here. I could actually represent this in a different color. Whatever, that works. So if I'm like looking at this direction right here, and that's where I clicked the block, and I clicked this face somehow, and then I flew over here, and now I'm like up here now, and I'm now facing like this. How do I get that intersection where this is going to intersect where this new area that I'm looking is looking? Because technically I could be looking offset. Like I could be looking, let's say I could be down here looking this way to where there isn't an actual intersection. So how do I figure out you know what? I think I know how. Like if I hold right click and I take the normal of the face, then I will multiply the normal with the distance from here to the player's location. So normalize DST from oh wait, no, not normalize. So n equals normal. Then d is equal to direction from click to player not normalized. Because then that'll give me, let's say the normal is 0, 0, 1. So that's going to be 1, so going north basically. Well, if it's going north, then the first 2 coordinates are going to be zeros. So if I multiply this direction with that distance, that's literally just going to give me well, I need the distance, not the direction. But yeah, same concept applies. I'm too tired to implement it because I'd have to completely redo this loop. Because right now it's raycasting, and I wouldn't want to be raycasting. I'd want to be Obviously, getting the player location, and then maybe I'd raycast. I don't know though. I'd have to raycast in some way. I don't even know what that would be called, so it's like hard for me to even ask ChatGPT on how that would work. Because like what I'm thinking of would work, 100%, but it's not gonna work as good because I do need to add some type of checking of the actual ray because I do want to be able to be over here and have the block still appear in front of me to where I'm not actually looking even at the same face anymore. Like, notice how I clicked on this face? Well, if I'm over here, I'm not going to be able to even see that face anymore. And I still want that block to be placed. Whereas the way this would work would be that block would stop right here. And it would not generate over here. As well as it would not generate over here if I were to have looked at this direction instead. It's just always going to be right here because that's the direction, or that's the distance basically of my player. But the distance of the player gives me a good approximation. But it might not even actually be helpful. I guess what I could do is check I could just use the ray, and at that range, I'll check that 10 range, and wherever that x coordinate is or whatever. No. Because then that ray could be like, let's say this is 5, then that ray is actually going to be out here, and then the x coordinate would be here. So then the cube would be here, which I don't want. But I could get it where the... So if this is the x plane, this is the z plane, then I could get it where the z plane crosses. Because wherever the z plane crosses, that is basically our intersection point. And if it doesn't cross, then I use... I don't know what I'd use. There's going to be a lot of ifs. If this, if that. And a lot of it is all based on this normal. That's where I'm like, I don't... Because I'm going to have to do like a bunch of switch case statements just to figure out... Because that's why I like this normal thing. Because like if I got the normal, then I could just multiply it. And that just gave me like the exact position almost. Or the offset from here that I had to fill in. One thing I do want to do, because I'm probably going to forget about this, is we're going to do a dictionary of vector 3s like this. Dot key dot values. I'm going to set this to private just for now. And then, well, actually, it might be private completely. Public void add chunk to update list. Chunk vector 3 in chord. Chunks to update dot add chord chunk. Add, and then we'll do C chord add to chunk update list, and then this is going to be swapped around, I think. Then where else? Okay, now that's the exact same thing. Except for add here is going to do if it does not contain the key. And it adds it. This is going to allow me to edit the voxel when I'm doing that like weird intersection thing for all these voxels. I'll basically create the chunk. Let's say this is my chunk border right here. It's going to know that it needs to do all these different blocks, but there's multiple chunks in between. So it's going to do this one, this one, this one, this one, all of them, all the way down. And it's going to create the chunks, and it's going to populate those specific voxels one at a time. And then it will, oh dude, I don't even know how I'm going to do that because it's going to have to deal with intersections too. Or like collisions. Because like the way I was thinking about it with this whole intersection or array thing is like, then let's say there was a block right here. And then I ended up looking right here. It's going to replace that block. Unless I only edit the voxel if it's already air. I could do that. Or it could... Not sure. I guess the only thing I could think of is it checks that area, like it tries to place all these blocks one at a time. Then once it hits an intersection or a block that already exists or anything, then it just stops and it breaks out of the thing. It just stops trying to continue on. Which would be good. Then also here, I want to add another bool. Public bool holding block equals true. if holding block, or if not holding block, return or yield return null. Well, I mean, I guess I could just return this, right? It's not like I'm missing out on anything. Same with this right here. We will do if not holding block, return. And obviously that'll get changed because eventually you'll have like an inventory and you'll have to like hold the block in the inventory and stuff. But for now, that's a good test to be able to like, not a test, but like, that's just good for the future sake of like being able to test other things without having to deal with the whole right click thing. Because I wanted to kind of get a an interaction thing to where it's like shoot. Yeah, I want to be able to interact with blocks so that I could like open inventories of a block or something like a chest, or add block interactions when it comes to actually like right clicking them. Maybe I could check and see if the block that I'm trying to click, like right here, I could then do the destroy pause if destroy pause. I could do if dimension dot get voxel destroy pause equals 2. Damn. Actually, I could just do that here. If place pressed else, we'll do that. Then we'll do debug.log block interaction event triggered. Pretty lame event, but it should work. Which means I can then come into not dimension but chunk, because where I'm populating the voxel map, I can then do voxel map of 0. Actually, we'll just do 15, 15, 15 is equal to 2. Because in that top right, it's all separated by itself. One thing I'm still not sure about is adding custom meshes. Because I think I've tried it before and it didn't work. Wait a minute. I can't do anything now. Oh. What is happening? What the fuck? Okay. Let's get rid of this. And let's actually get rid of that whole holding block thing, because I think at this point it's actually checking anyways. Down here. Bro, what? Something very strange is happening. And I'm not sure if it's this. I don't think so. I think it's this. How I changed this to chunks to update. Clear. Down here, I want to do add to chunk to update list. Chunk. C. Get rid of that. And then bring that back. Three errors. That's good. Oh, if chunks contain. That's why. Yeah. 100% that works now. And we have block interactions, which was a lot easier than I thought it was going to be. And then I should be able to break that too. Perfect. Now, one other thing I do want to do, because I'm about to get off, is I want to change this chunk object game object parent set or transform set parent dimension game object or dimension transform. I don't know if just setting the parent with like transform.parent is equal to dimension.transform is quicker or better. But I know like the layers is better to set with like the function rather than just directly. Yep. And it all revolves around this. So if you guys ever need it, right there. Just make sure to understand how it works. But like overall, I did this all from scratch right here. So I mean, I could do this from memory any day of the week. I could take probably a year off of Unity and still be able to remember how to write down this, as well as generate pretty much everything here. This, however, I feel like is a bit much, and it could probably be simplified quite a bit. UVs is not correctly set up, but that's because we don't have blocks yet. Eventually we'll have blocks, which will have like each block will have either a custom mesh or it'll have basically it's geometry. And I'm not sure if I'm going to do that with prefabs or what. I just don't think it's a good idea to do prefabs. Actually, you know what? No, it is a good idea to do prefabs. No. Maybe? I don't know. I think it's probably not a good idea. Because regardless, I'm going to want to transfer the mesh data from the prefab into the actual chunk itself. So if I did a prefab, I'd probably get confused and forget that the mesh filter, mesh renderer, and all that kind of stuff has to be on the main object. It can't be on like the children or something. Which is also another thing that I'd have to consider. Objects that have multiple bones to them, or like multiple meshes. How am I supposed to handle that? I know Unity has like a combine meshes function, so maybe I could do that. And then I'd add like a loading system, so like before you ever enter a game, you'd have to load all the models, and that all that would really do is just go through every block in the registry, make sure that the block can turn into a single mesh, because we do not want multiple meshes when it comes to a chunk. Because if we're placing these blocks, and let's say I place a full chunk, I don't want to have what is it, 256 or something like that, different blocks, all consisting of their own game objects and own mesh renderers and all that. I want it to all be shared. Actually, you know what? I might not be able to. Yeah, I don't think I can. Because well, I just have to figure out how to do the texture atlasing because I'd have to do that on the load as well. I'd have to like generate that. Otherwise, I'd be setting myself up for the most annoying setups of having to make a sprite atlas every single time I make a new texture, which means then I'd be changing the texture size and having to change the code for that. I'd rather just have a loader that can take every block, all of their textures, combine it all into a single atlas, and then just like pre-generate some IDs for everything so I know where the UVs need to be for what block and what this and that. I don't think it would be that hard though. Actually, you know what? I take it back. It would be pretty hard. Because when it comes to the objects that are not just straight 16 texture, they're like weird texture sizes, they're the UVs on the object is all weird because it's a custom model. Having to generate a sprite atlas, taking all that into account is just a pain because it's gonna screw up all of the other stuff. I don't know. I'll probably figure it out as we go. But I'm tired, so I'm gonna get off. We did get quite a bit done though. I mean, code wise, it's not that much. We got like what, 150 lines. Get rid of this. 116 lines. None. 40. 50. 80. And 30. So overall, like what, 350? 350 lines, maybe a little less. 300. Actually, what did I say? Here, I'm gonna add it up before I get off. Normally, I don't really pay attention to how many lines I write. But since I've streamed this whole thing, I know how long it took me to write all this, so I'm actually kind of curious. And I was definitely not being efficient with my time. There was quite a bit of things that I was just like, I was tired, and then I also went out to go let the dog out, and you know. That's pretty compact. This one's pretty compact as well. So 154. 154. Actually, 152. 112. I'm just doing it to where the last line ends. Because obviously code is so I could make 1,000 lines of code out of what we have here if I wanted to. 39 plus 49 plus 78 plus 32. 462 lines of code. Ask ChatGPT how many lines are considered good in the amount of time we just streamed. Okay, it's not giving me a very straightforward. 150 lines of code in 6 hours is good? You're kidding, right? Okay. Well, it's giving me a bunch of different things like UI, gameplay, programming. I'm making a voxel based mesh generation code with, well, oh, Jesus. Okay. Shaders for custom rendering, optimizing performance, draw calls, chunking, multi-thread. Okay, I am doing chunking. But no threading. No marching cubes or greedy meshing. Currently, just cubes with base rendering on voxels that are empty on the neighbor block. Well, how many lines? Face calling, it's saying, is about 150 to 400 lines of code. No shot. I mean, I guess if you have like transparents, but not even then. Like, I'd probably add like, I mean, 10 lines of code to cull the transparents, and then okay, maybe more than that because I have to separate it into its own object and have a new material. Overall, maybe 150 extra. But that's a complete like overhaul of a lot of things. And it wouldn't be just for transparents, it'd be for other things too, like water. Mesh generation is about 400 lines, like 150 to 400. Okay. I got 462 lines of code. 462 lines of code in about 5 hours. I started from scratch and now have a chunk-based voxel cube generation working. I also implemented raycasting for destroying and placing blocks. Both the raycasts and the updating of chunks meshes are handled in an IE numerator set on a 20 tick interval per second to reduce unnecessary performance loss. Also made a free to fly around and a debug screen that only shows FPS. I've never looked at, that's impressive for pooling chunk meshes? What does that mean? Occlusion culling could reduce further unnecessary face rendering. I'll probably add that at some point. I'd use a dot product of the normal of the face being displayed or trying to be drawn. No. How would I do that? I'd have to separate the faces into their own meshes. And I'm not trying to do that constantly. I just feel like I'd lose performance doing all that. Because like right now, what is this? Just this base mesh right here. It's a single chunk. It's about half full. And this is more than if it was a super flat. Even if it was completely full and a super flat, it would be less vertices, I believe. So this right here is about 43,000 vertices. Holy shit. It's a lot more than I thought. Yeah, I mean, I guess that makes sense. Maybe I work on greedy meshing. No, actually. I think greedy meshing comes after I do the UVs and everything. Because right now we have UVs, but again, when it comes to actual voxels or different blocks and textures, I'm pretty sure I'm gonna swap it out to shoot, what do I call it? I'm gonna swap it out to like a texture atlas, which is then gonna, I'd have to rework the whole greedy meshing system to work with the UVs. That's the one part about the greedy meshing that I don't want to, I'm not looking forward to. But I genuinely think I could do it without ChatGPT, because ChatGPT gave me a big ass thing of code when I was just like asking it for a greedy mesh. Because I did this before, and then asked it to like take my code and just add greedy meshing to it, and it just like redid a lot of things, made it so complicated I didn't really understand what was going on. I guess I was just overwhelmed. Maybe I did understand it. I just like I looked at it and I was like, I don't really want to deal with this. And then I tried the code and it completely broke it. I mean, like only the bottom cubes were even being rendered, which in my code was like the opposite. It was literally supposed to render what's being rendered right now. But yeah, it was only rendering the bottom, and then the bottom was like completely broken. Like the top faces were not rendering. The bottom was, and the sides were, but the inside faces were all rendering too. But I mean, greedy meshing would be so nice right here, because like this would be all one mesh or one big quad, and this right here would be its own quad. This would be its own quad. Then looking on the top, this would be a quad. This would be a quad. That would be a quad, 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 quad. And then this would be just one big quad right here. And then in the front, we'd have one quad, two quad, three quad, four quad. I mean, just imagine the amount of vertices saved doing that. Obviously, if it was like super chaotic terrain, it wouldn't really save anything. Like doing what I'm doing right now would not save performance with greedy meshing, really. But I guess, yeah, maybe, okay, what I just built would, because like this right here would be one quad. That's basically having the amount of vertices. That'd be a quad. That would be one quad. That'd be a quad. That'd be a quad. That'd be a quad. Yeah, so I'd basically do half the amount of vertices, even with this. Like super messed up terrain. Let me, real quick, turn off single click. Are you planning to add more gameplay features next or focusing on optimization? I mean, the goal was gameplay, because like the whole point of this was like a test to kind of just mess around and see what I could do when it comes to. I wanted to do block interactions because I've never done that before. I also want to add a ticking system to certain blocks so that they could tick and have their own ticks. However, there's a lot of work that needs to be done before I get there, because like I could add ticking right now, but one, we need actual blocks so that the blocks have something to tick, like they need their own behaviors. Now we're at 79,000. We're still not looking great. But like a lot of this could be reduced with greedy meshing. See, I can do greedy meshing on my own when it comes to the vertices. I'm pretty sure. I've done similar techniques before. Just not with actual meshes. I did it with the block bench cubes. So like if I go here and go to bedrock block, I guess it would have been entity or something, but like imagine I drew a texture like here. like that. And then what I wanted was to be able to convert this into a 3D model just from the texture, like how Minecraft's cubes work, or their items. So what I would have had to do is basically generate a 1 block wide cube and see how go to in. Now that matches this bottom row. Well, at first what I did was every pixel that's not transparent, it got its own cube. And I generated in Unity, I made a code that would generate a 3D model for Blockbench using a texture. But the very first iteration was using a single little pixel voxel or block for every pixel that was not transparent, or that was fully transparent. And then I realized the performance that you lost on that sucked, and so I was like, you know what, maybe I could add some, like, I didn't even know about maybe I knew about greedy meshing, but I didn't think of it as greedy meshing when I did it. I was like, you know what, I could probably just do columns or something and like go over each column, go all the way up, and once I hit an area, then I could start going over. Well, actually, I can't do that. I think I just did columns. No, maybe I did go over. I'm just trying to think of how I would have done that. But I would have started over here, went up, realized that that was like that. I thought I would have started down here then. And yeah, I'm not really sure how I did it. But anyways, I implemented a sort of 2D greedy meshing system, and so I'm fairly confident that I could do greedy meshing on my own. It's just the UVs that's going to be kind of a challenge. But if I know that each voxel is supposed to have a 16 pixel UV, then if I greedy mesh 3 voxels together, then obviously I just multiplied the original width of the thing by 3. I mean, it's as simple as that. Yeah. I don't know. Probably add a save system eventually too. But I'm not sure exactly what I'm going to do next. I think the block system is going to have to come in next. Because once I get blocks, then I can start adding textures to the blocks, and then I can start working on the custom geometry stuff, which would be nice. And transparents are another thing I want to do, but I think I'll hold off on transparents for right now. Because first I have to do blocks, then transparents kind of come in at the same time as the custom meshes, since I'll be having to do sub meshes per chunk. And transparents are a sub mesh because it has to have a separate material. I just don't know how many sub meshes you can have. Here, I'm gonna look that up.